today, I think what's inspiring is two things. One is the people I work with, my collaborators, grad students, postdoctoral fellows, are extraordinarily wonderful people to work with. They're brilliant, they're motivated, they're dedicated, they're accomplished, they're just cream of the crop. And in another sense, it's because I work on climate change, and climate change is a very real, very practical, very serious problem for the world. So it's different from working on, say, stellar evolution, which is interesting but doesn't have any immediate consequences for the world. And so my hope is that together with many, many other climate scientists and a lot of other people who care about climate, I can make a difference, and I can help the world to cope with a problem that is very real, very serious, and going to get worse. I was just fascinated by weather, and I thought I would probably become a weather forecaster. And when I went to college, I majored in meteorology. And in fact, I was growing up in the Virginia suburbs of Washington, D.C. And I just looked around in choosing a college and tried to pick the nearest one that was really good in meteorology. I picked Penn State, which was then, is now, a really predominant, excellent school in meteorology. A lot of the people who are weather forecasters have Penn State meteorology degrees. I had summer jobs working for what was then called the Weather Bureau. I worked at Washington's National Airport one summer. I remembered taking weather observations, plotting weather maps. I once closed down the whole airport because the visibility dropped below a certain threshold, and it was up to me to decide when that happened. So it was a great feeling of power for a kid. I'm what's known in the field as a climate modeler. That is, I work on computer simulations of the climate system. And that was a step away from wanting to be a weather forecaster, of course. While I was in graduate school, I learned what research is. And I think the biggest step after that choice was deciding to come to Scripps Institution of Oceanography. And that happened when I was 38. For me, it was a remarkable transition. I came here at age 38, never having written a proposal in my life. I was started as a full professor. I was at the top of the academic ladder starting out, and very naive. I didn't know what a proposal was. But I quickly learned that what I was doing, I had traded the resources of my previous places for the freedom, the autonomy, and the risk, if you like, of deciding what I wanted to do, finding the funding, and being my own boss. And for me, I just like chocolate better. I mean, it really worked for me. People have spent their whole lives, had wonderful careers in block-funded federal labs, but for me, I discovered when I got here, in early middle age, you might say, at age 38, that I was born to be a university professor. I've been extremely lucky in many ways, and one of the ways is that my career has spanned the time of huge growth in this field. And I can tell you the numbers. When I was a grad student in the early 1960s, my PhD is from 1966. When I was a grad student, there were 14 universities in the US that gave PhDs in atmospheric science or meteorology. And today there are more than 70. And so there's been, in my career, a five-fold increase in the number of universities. So for example, Scripps at the time didn't have an atmospheric science curriculum or didn't have atmospheric scientists on the staff. I was the first one hired to the faculty. So it's one of the places involved in the growth from 14 to 70. And that growth in number of universities involved was paralleled by growth in faculty positions and in research dollars and in resources of all kinds. So I've just seen a huge explosion in the resources available, which is not going to happen again. There's not going to be 5 times as many. It's not going to be 350 universities, if you look 40 years, 50 years from now. Well, I would say examine your motivation. What's driving you? You have to be passionate about it, because you're going to be competing for everything, for jobs, for resources, for proposals, and so on. You're going to be competing with people who are probably just as smart as you or smarter and have just the same work ethic and so on, but who are absolutely passionate about it, who would rather be doing this than anything else. And So everybody that's any good in this field works a whole lot more than 40 hours a week. I don't know how you'd be a successful scientist at 40 hours a week, but I don't think you can be a successful movie actor or anything else if you think of it as a job. So it's a passion. So it's a little bit like what I suppose many parents tell their children, find out what you love to do, and after that, find out a way to get somebody to pay you to do it. And I think in terms of practical advice, if you want to have a shot at doing research, go and first of all get very well prepared in basic science, in math and physics and chemistry. The other thing I tell people is English, that this is a field in which communication matters. The last thing that scientists do is give talks and present papers and publish. But if the sciences attract you, a young person trying to decide what to do in life, then I think it's good to consider earth sciences because you are going to be dealing with things that matter to people. You're going to be dealing with things that affect the environment, that affect the economy, that have implications for people's lives. And so, for example, I worked on weather forecasting for a long time, and I think in a very tiny way, I and many, many, many other people helped make weather forecasts today better than they were 50 years ago when I was a student. And that's a great feeling because weather forecasts matter to people. Weather forecasts save lives, for example. Weather forecasts help farmers and airlines cope with weather emergencies. And so you are really having an effect on real people and on the planet. And to me, that's very rewarding.